This is a praying mantis. It stays motionless, as if it were just another stalk of the plant, waiting for prey with nothing else on its mind. Below, ants bustle past until one strays too close, and right then the strong, spiny foreleg sees it. One more second, and the ant is dead. The mantis knows exactly what it's doing. It's the top of the food chain in the insect world, an apex predator, almost like a shark or a tiger, only smaller. No one dares to challenge it, but these ants have a strategy to win. But first, they need to die. Attack of the Non-Titans. An unobtrusive reminder to do that thing under the video. Alright, to make sense of it all, let's rewind a little. The mantis killed the ant without a second thought. But at the very moment of death, something truly important happened. The ant released pheromones, chemical signals that work like a siren for the rest of the colony, and the other ants rushed to answer that call. The first to appear on the battlefield is the soldier. It climbs onto the mantis's head and locks onto its mandibles. That's how the predator is stripped of its main weapon. It can no longer bite or kill. And while it thrashes, trying to break free, the entire army charges in. Then the ants overwhelm it with numbers, clinging to the mantis from every side, one layer after another. There are so many that they blanket its whole body, stripping away any chance of resistance. Even the weight of this living mass plays a role. Hundreds of little bodies press the apex hunter into the dirt. Escaping is nearly impossible. And that's just the beginning. Because after that, the ants, moving in sync like a crowd of surgeons, begin to dismantle the enemy, piece by piece. Someone holds, someone pulls, someone snaps the joints. And at last, the final push, detaching the head from the body. From then on, the apex predator turns into a grocery basket, easily hauled away to the shared storage. The fighters, tough enough to take down a mantis, are called driver ants from Africa, sometimes safari ants. Their colonies live on the move, alternating long marches with periods of rest and egg laying. During the nomadic phase, they're on the move every day, sweeping away everything in their path. Their powerful cutting jaws spare nothing: snakes, birds, mammals, even humans. But that's far from the only thing driver ants can do. During the rainy season, they make hunting trails. It's not just a long line of insects rushing in one direction. No, sure, others might move like that, but not driver ants. They're simply too smart. Worker driver ants really do move in a straight line, from the food source to the nest. But along the edges of this trail stand the soldier ants, big with massive jaws, blind, and at the same time insanely sensitive. Their bodies form a wall, and sometimes even an arch, turning the passage into a tunnel. The workers rush inside, under cover, while on the outside, you only see the soldiers' heads sticking out like spears. It looks like a fence topped with barbed wire. Touch it, and you'll get grabbed. The soldiers are wired to keep the trail moving at any cost, or die trying. So for any insect or arthropod, such a trail is a deadly trap. The moment it gets close, the fence comes alive and lunges forward. And all this stretches for hundreds of feet in every direction from the nest. An entire network of roads spread through the forest. The ant flow never stops. If a scorpion happens to wander onto such a trail, that's the end of it. Even its deadly stinger is useless here, because it can't strike all the ants at once. There are just too many of them. All of them join the fight, workers and soldiers alike. Everyone's busy with their own task. Some look for weak spots in the joints of the limbs where the chitin armor isn't so tough. Others dig straight into the protective plates on the body. The massive mandibles of the soldiers snap like a can opener. The scorpion might try to fight back, of course, but the crowd will still pile on top, pinning it to the ground. Its venomous tail won't rise anymore. In the end, the scorpion will be trapped, immobilized, and killed on the spot. Ants need just 20 minutes to take apart their prey and carry it back to the nest, leaving nothing behind but a wet spot where the scorpion was. There's even a case where a person saw the fight start, ran to get a camera, and when they came back, there was only a stain on the tree where the scorpion had been sitting moments before. This is a tree scorpion, and at first glance, it looks like a fierce opponent, especially compared to weaver ants. It has a big body, a sharp stinger, and pincers that pull prey close to pierce it. The scorpion moves with confidence because it doesn't have to fear anything. Its body and legs are covered with super sensitive hairs that pick up everything happening around. This is a hunting tactic that works well against insects like ants. However, one weaver ant spots a scorpion close to the colony, but it doesn't run or hide. On the contrary, it rushes in to attack with zero chance of winning. The ant grabs onto the pinchers, takes hits, and of course the scorpion easily kills it. But that's exactly what's needed. The dying ant releases a chemical into the air, a pheromone, a siren for the whole colony. Familiar strategy, right? Other weaver ants come running at the signal. More and more of them show up. They surround the scorpion from all sides, grab its legs, tail, bite wherever they can reach. But there's also a secret weapon: toxic gases. Every ant, while holding the scorpion, releases an acidic mist from its abdomen. Invisible to the eye, to the scorpion, it feels like molten lava being poured directly onto an open wound. The scorpion struggles, and of course, the ants die. But every ant that dies is replaced by dozens more. At some point, there are so many ants that they can even hold down the venomous tail. The predator's main weapon is taken out. The scorpion's pinchers can only grab a limited number of ants, and there are too many of them, and the scorpion loses. Weaver ants tear it apart piece by piece, biting through the soft tissues at the joints. When the stinger is separated from the body, the fight is over. All the parts are taken back to the nest to feed the colony. Actually, this tactic works on any enemy of the weaver ants. At the front, they have huge, incredibly strong mandibles that act like a hydraulic press, only with sharp ridges on top. If you scaled the strength of these mandibles to human size, one ant could lift a 7-ton truck into the air. Any intrusion into their territory is met with fierce aggression, and one of the most effective tactics they use is immobilization. The ants attack in swarms, assigning several ants to each limb. Some grab legs, tails, or whatever they can from different sides and pull until the victim can no longer move or fight back. Meanwhile, others bite, sink their jaws into weak spots which still need to be found. After all, the bodies of many victims are covered with hard chitin, like armor, and can only be pierced with precise stabs at the joints. Such a coordinated attack can turn even a fearsome enemy into a motionless target, and in just a few minutes, the battle is over. The victim is drained of energy, and the weaver ants get their prey. But since we're talking about scorpions, it's worth noting that some ants prefer to fight them one-on-one. On one side of the arena is an ant from the genus Odontomachus. On the other, a marbled scorpion. And it's important to stress right away, this is different. There's no crowd overpowering the enemy with sheer numbers. This fight is purely a duel. The marbled scorpion isn't big, but its pinchers are perfect for grabbing and killing ants. It sneaks up on its prey, and it might seem like the ant is entirely doomed. But everything changes in a second. As soon as the ant spots its opponent, it charges. Again and again. It shifts positions, attacks from different angles, aiming at the legs and tail. Every strike lands at lightning speed. And the strategy works. In this duel, a single ant faces one scorpion, and the scorpion, disoriented by the strikes and bites, soon stops resisting. Why? The secret lies in the unique jaws of the trapjaw ant. They're huge, like scissors, and move at speeds of 78 to 140 miles per hour. That's 2,300 times faster than a blink of an eye. The jaws are equipped with a pair of locks, and when the energy is released, the jaws snap shut instantly. The locks are the key to everything. But to understand how they work, imagine, for example, a bow and arrow. If you try to throw an arrow by hand, it won't fly far and won't have much penetrating power. But with a bow, the energy stored in the string is released almost instantly when you let go of the arrow. And now that arrow is truly deadly. If you listen closely, you can even hear a snap when the jaws slam together. In fact, that shockwave is a pneumatic shot, capable of stunning its prey. In the end, the ant does call for backup, but only to finish off the victim and drag it back to the nest, because it simply can't carry the scorpion alone. That's when the jaws and venom come into play. The toxin seeps under the scorpion's skin, paralyzing it. And that's the end of the battle. But you know what? Scorpions aren't the limit because ants can actually kill snakes. Animal behaviorist Sean O'Donnell was having coffee after lunch when a giant earthworm burst out of the fallen leaves in an Ecuadorian nature preserve. Its length, as it turned out later, was nearly 16 inches. And then a whole column of army ants appeared. Hundreds of tiny insects attacked the worm at once, quickly paralyzing or killing it. This observation, along with another one where the same type of driver ants were feeding on a snake carcass, led O'Donnell and his colleagues at the University of Washington to propose a new theory about the origin of cooperative hunting in these insects. It's thought that the mass collective search for food, a key feature of driver ants' behavior, originally evolved as a way to take down large prey. In other words, the ants started teaming up specifically to get a lot of food at once. Hunting large prey together, scientists suggest, later became the evolutionary precursor to chasing smaller prey. Researchers also said that this species seems to be unique among the New World army ants. It doesn't just attack vertebrates, it actually eats their flesh. Other driver ants sometimes sting or kill small vertebrates like lizards, snakes, or birds, but they usually don't use them as food. In that sense, driver ants aren't just killers, they're highly organized hunters who know exactly what they're doing. All right, it's more or less clear when it comes to scorpions, praying mantises, and worms, prey that ants can stun and tear apart fairly fast, but driver ants are capable of more. Today, they've got a crab on the menu, a catch larger than scorpions and mantises put together. First, the ants do what they always do, cover the potential prey with a carpet of bodies, but the crab isn't a praying mantis. It's hard to crush with weight, and its whole body is protected by a tough shell. The ant's jaws just aren't strong enough to pierce the exoskeleton. What's left? To look for weak, vulnerable spots in the armor. One group goes for the eyes. There's no defense there. Another carefully targets the legs and claws. And this group takes the biggest risk. The crab doesn't give up without a fight, and some ants die. But their sacrifice isn't wasted. As for the legs, the ants aim for the soft tissue around the joints, and the jaws work like scissors, slicing through the flesh. When the big ants make deep wounds, the small ones join in. They crawl inside, reaching all the way to the muscles. There's also a third group, aiming for the crab's mouth, another weak spot. The big ants pry the mouth open. The small ones squeeze in to bite, attack, and tear the prey from the inside. Such a coordinated attack leaves the crab no chance. The ants slowly eat it from within, turning a large armored prey into a canned food. Oddly enough, crabs quite often fall prey to ants. The yellow crazy ant also hunts crabs, though this species has a totally different tactic and its secret weapon. These ants lie in wait for their prey during the seasonal migration on Christmas Island when crabs are forced to pass through the forest. Ants running by don't even bother inspecting the body or looking for weak spots. They act instantly. They shoot. Although yellow crazy ants don't bite or sting, they spray formic acid. It's both a defense and a way to subdue prey. In places with a high ant density, the movement of a land crab triggers an instinctive reaction. Acid gets sprayed everywhere around. The toxin level on the ground quickly overwhelms the crab. It goes blind, then dies from dehydration and exhaustion trying to wash the acid off. As dead crabs break down, their protein becomes available to the ants. Studies show that ants have displaced around 15 to 20 million crabs, killing, eating, and using the crabs' burrows as their nests. Even baby crabs fall victim. They have no protection and no chance to fight back. It all started when, sometime between 1915 and 1934, people accidentally brought yellow crazy ants to Christmas Island, and the ants liked it there. By the 1990s, they'd started forming huge super colonies with millions of workers and thousands of queens. To put it in perspective, one super colony found in 2002 covered almost 1,900 acres. Scientists call these ants unicolonial, which means their colonies don't attack each other. In other words, they live in peace, reproduce, and take over new territories without trying to compete with one another. But everything else that moves is fair game, including crabs, which actually are native to Christmas Island. But let's go back to the driver ants and take a look at this slug. It might seem like easy prey for the ants since it has no venom, claws, stinger, basically nothing to fight back with, but that's an illusion. The ants really have to work for it. One ant finds the slug and calls the others. they surround it from all sides, covering it with a thick layer. The slug tries to escape, and the only way it can, it drops from the branch, but it doesn't help. First, the ants fall right after it. For them, this is a usual and quick way down. Second, the slug lands right on the trail where there are even more ants. But that's not the end. The slug has a secret weapon. Its body's covered with a thick, dense layer of slime. The mandibles of the ants, even the biggest ones, get stuck in it for good. The slime's so sticky that once their mandibles sink in, the ants just can't get out. They try to help each other, but it's impossible to help everyone physically. Some get stuck too deep, their heads and legs trapped, unable to move, and just when it seems like the slug might actually fight back, where the scorpions failed, the ants pull a special trick. Some workers leave and come back with clumps of soil clenched in their mandibles. They start surrounding the slug from all sides, and there's so much soil that at some point the victim is completely hidden under a layer of dirt and swarming ants. The soil soaks up the slime, stripping the slug of its defense. Once the slime is gone, the slug is doomed. The ants eat it. The hunt was a success. What's next? Oh, a huntsman spider, another fierce predator on our list. Instead of spinning webs like most spiders, huntsman spiders actively stalk their prey. This prey includes insects and small invertebrates, depending on the size of the spider itself. Huntsman spiders can move really fast, up to 35 inches per second, and some species can even do a wheel or a backflip on the run. Not sure if that helps with hunting, but it definitely looks impressive. So the huntsman spider, it's well camouflaged, which makes it even more dangerous. But here's the catch. The spider has to share its territory with the jackjumper ant, a species known for being able to jump long distances, plus a powerful stinger, big jaws, and aggression. Noticing a spider near its nest, the ant jumps on it from above without a second thought. The spider clearly didn't see this coming, and at first doesn't get what just happened, but then decides it's a food delivery. It grabs the ant, shoves it into its mouth, and that's a fatal mistake. The next moment, the spider throws the ant off, because at the very moment of the bite, the ant had plunged its venomous stinger into it. By the way, the jackjumper ant and its relatives from the Myrmecia genus are among the most dangerous ants and have a fearsome reputation. Guinness World Records officially names Myrmecia piriformis the world's most dangerous ant. As for our hero, some sources say its venom is 4 times stronger than a bee's. It hits the spider's cells and organs, causing partial paralysis. And yes, the ant bit, it died, but the pheromone siren is already triggered, which means a whole squad of bulldog ants is heading for the spider. Soon they're already on the spot and already grabbing the spider by its legs, stretching it in different directions. The spider manages to strike one ant with its jaws, but it's not enough. These ants are too aggressive and don't know how to stop. Once they start a fight, they'll see it through to the end. Another group of ants comes at the spider from behind. They deliver new bites, weakening their victim more and more. The venom starts destroying the spider's internal organs, and any further resistance is pointless. In a few minutes, the victim is dead. By the way, according to a 2024 study, tarantula hairiness acts as a defense against driver ants, which crawl into their burrows and could eat the spiders alive. You've probably seen how that happens. But when driver ants were spotted rummaging in the burrows of South American tarantulas, they usually ignored both adults and offspring. In rare cases when ants did attack, the tarantula's stiff hairs provided solid protection. Researchers mention this separately. The thick hair covering a tarantula's body makes it tough to bite or sting the spider. From this, you can guess that tarantulas became hairy specifically because of ants. They adapted over time. This hypothesis fits with earlier observations. Burrowing tarantulas wrap their egg sacs in hairs so that wandering ants can't eat them. Moreover, scientists found that less hairy tree tarantulas, potentially more vulnerable, have come up with other ways to protect themselves. In one observation, a spider was hanging on the tip of a leaf, escaping from driver ants hunting for prey. And now that we're talking about South America, in the Brazilian rainforests, a grasshopper lands on a leaf, and that seals its fate. It's counting on a quick snack. But that leaf belongs to a Cecropia obtusa plant, and it hires hidden bodyguards, ants. Beneath the leaves hide thousands of Azteca Andrea ants. The moment a stranger touches the surface, the ants rush in, latch onto its legs, and pull in different directions. The leaf turns into a medieval torture rack. Some ants hold the victim, others bite, sting, and tear it apart. Think that other species have done this before? Not really. The fact is, a single ant weighs only a little more than 0.00003 ounces, while their prey, grasshoppers and moths, can reach up to 0.3 ounces. Of course, ants are famous for being strong and for hunting in huge groups, but even then, tackling a bug that's roughly 10,000 times your size is no small task. It's the same as a bunch of people trying to restrain 3 struggling blue whales. But the ants and their host plant work together. The ants' tiny claws cling to the velvety, fuzzy underside of the leaves, and together they form, well, something like Velcro and miniature hooks. And once you've got a steady grip with your legs, holding up 3 blue whales or a single grasshopper is way easier. By the way, the secret behind the ants' incredible grip was only uncovered recently by a team of French and Spanish scientists. To test the worker ant strength, tiny weights were hung on threads in front of the ants. It turned out that one worker can hold up to 0.3 ounces. That's 5,700 times its own weight. Just imagine what they can do together. Their relatives, Azteca brevis, living in Costa Rica, keep up as well. They've come up with their own unique way of catching prey much bigger than themselves. On the branches of trees in Piedras Blancas National Park grows a strange fungus. It leaves behind a dark coating and softens the bark so that ants can gnaw tiny holes in it. For them, these are not just little hollows, they're both shelters and traps. An ant sits quietly inside until some random insect happens to pass by. The moment its leg slips into the pit, the hunter instantly grabs it and pulls it down. The trapped insect jerks around, trying to break free, but only makes its situation worse. Other legs get caught in nearby hollows where more ants are waiting. They grab hold and start pulling too, turning the victim's struggle into their own advantage. In the end, the insect is stretched out and practically pinned to the branch. There's no way for it to get free anymore. What happens next depends on the size of the prey. If it's a tough opponent, the ants just hold it until it weakens and dies, sometimes for hours. But if the victim is smaller or weaker, more ants climb onto the branch and the whole swarm throws itself at the prey. The outcome is always the same. The insect gets eaten right there where it fell into the trap. And yeah, this strategy seems almost unbelievable. But that's exactly how little hunters manage to take down an opponent 50 times heavier than themselves. And there's another ant that doesn't quite match the topic of this video, but I just have to mention it. A small brownish-red insect makes its home in the trees of Borneo. And at first sight, there's nothing remarkable about it. No huge mandibles, no venom, an easy target for any hunter. But this ant hides a secret. It can explode. When an ant feels threatened, it raises its hind legs, a warning sign. If the enemy doesn't back off, it all ends with self-destruction. The ant bites its foe, sharply tightens its abdomen, and tears itself apart. At that moment, a sticky, poisonous, bright yellow mass bursts out. It smells surprisingly pleasant, like curry spices, but for the enemy, that smell spells doom. The sticky secretion glues the opponent to the branch, and in doing so, saves the colony. Researchers classify these self-exploding ants as Colobopsis cylinder. For a long time, people thought there were very few of them, and almost nothing was known about them. It was only recently discovered that there are not just 1 or 2, but at least 15 species. Even now, scientists know very little about them. One thing's certain, exploding is their defense mechanism. But who knows, maybe they also use it for hunting. To blow up near potential prey, sacrifice themselves, and feed the colony? That sounds very ant-like. But scientists still have to test this. You owe me a like. See you later.